Hello and welcome to session 256 in the AISafety.com reading group. Tonight we will be discussing the second part of Where I Agree and Disagree with Eliezer by Paul Christiano. Paul Christiano probably needs no introduction at this point, and we'll be going through part 11 through 19 of the list of disagreements. So the first thing that Paul Christiano asks is, where does Eliezer Yudkowsky find the evidence that he uses for talking about how difficult the alignment problem is? Well, the answer, according to Paul Christiano, is probably in his own experience on working with solving the alignment problem. Like, on the face of it, that seems a bit uncharitable in the sense that Eliezer Yudkowsky has seen a lot of other people try to solve alignment. But knowing from what I know about Eliezer Yudkowsky, I think I would not be very surprised if he is indeed basing most of it on his own personal experience. Then another thing that Paul Christiano asks is, society has apparently spent very little total effort on solving the alignment problem. So based on that, we can't really say very much about whether it's a hard problem or not. I'm not entirely sure I like that framing, because how much sure society could do a lot if we spent all our resources towards that, but that's not going to happen. I would agree. I would think that Paul Christiano also don't think we're going to get a fire alarm or anything like that. So we're not going to devote all that effort. So comparing it to the total amount of effort we could spend is probably not relevant. I prefer Nick Bostrom's concept of recalcitrance in how much progress do you make on the problem given a certain amount of extra input. There's a comparison with existing research fields and the problems that they routinely solve, and it seems like they're working in a different way and solving different things compared to MIRI, so we shouldn't update too much on the failures of MIRI. I think at some point I think we are comparing apples and oranges here, because the fields that solve problems routinely look very different from the pre-paradigmatic field of AI alignment. I don't think these can be compared in any particular way. Most existing research fields would also be quite incapable of dealing with pre-paradigmatic research. So MIRI tried and failed to find a coherent formula for corrigibility. Does that mean that corrigibility is unworkable? No, Paul Christiano says, because we don't have MIRI is just not competent enough for us to conclude this. So a small nitpick here is that the quote from the way that Paul Christiano quotes Eliezer Yudkowsky is technically not correct. He's splicing two quotes together, but that's just a nitpick. I think the real answer to this would be that MIRI spent a good amount of effort on this. They had something like 5 to 10 research papers published on this, and they gave up, of course. And then after that, for 5 years, no one was able to improve on what MIRI did. And I think that is a substantial amount of evidence that corrigibility is unworkable. As for the total difficulty of the problem, Paul states that Eliezer is certain about how difficult the problem is, and to some extent that flies in the face of the introduction, where Eliezer Yudkowsky in his list of lethalities post says that the problem may in fact not be that hard. In fact, he is giving the example of a textbook from the future that contains just simple solutions that work. So the problem may even be quite simple. It's just that we are not seeing, and we have a hard time determining which solutions are going to work or not. Right now we mostly don't know how hard the problem is, and that is very true. I do think that we have a significant lower bound in that the problem is almost certainly not easy. I think enough people have worked on solving the alignment problem that we can rule out most easy solutions. Disagreement number 12 is about Eliezer's understanding of science. Some of the things Eliezer Yudkowsky say seem to have a relevance towards science in general. For instance, the pattern of bright-eyed young scientists that ignore warnings from cynical veterans. That is something that Paul Christiano thinks is probably ungrounded. Three things that Paul Christiano thinks would ground this would be knowing more about the history of science, knowing how functional academic disciplines work, and having research experience. Of the three, I think Eliezer Yudkowsky probably knows quite a bit about the history of science. That's at least the precisely how much is a good. He's obviously not a real scholar of this, but I think he's very well read. I think the dynamics of modern functional academic disciplines is mostly irrelevant in the sense that alignment is a dysfunctional academic discipline. Research experience, you could say that he has been like a researcher most of his life. So some research experience could also be argued. But in general, I think that this is like Paul Christiano's criticism is to some extent correct. I think the place where Eliezer Yudkowsky has in fact experience and is able to talk about this with some degree of certainty is within alignment and like nanotechnology and these kind of pre-paradigmatic fields, which is kind of his specialty. So I think the patterns that he is saying, I would expect them not to hold in functional academic disciplines, but I think they might indeed be valid in less functional academic disciplines. As evidence for this, Paul Christiano pulls out a bet that Eliezer Yudkowsky made back in 2009, where he bet $25 that the Large Hadron Collider would not find the Higgs boson. And that turned out obviously to be wrong. Now, when I first saw this evidence, I was really meh in the sense that obviously betting at even odds is something you do if you're like 75% certain of something, and having a prediction that you were 75% on like so many years ago, that seems like really weak evidence to me. But then I looked into it some more and to see Eliezer Yudkowsky's reasons for this. And the reason he's giving is he doesn't think the modern field of physics has its act sufficiently together. And that is in fact quite relevant if we take Eliezer's position on this being that he doesn't think the modern field of alignment has its act sufficiently together. Like obviously Eliezer Yudkowsky should have updated on this back in 2009, but in general it's really hard for people to update sufficiently on evidence. So I do in fact think that Paul Christiano's point here is correct. Also, you might see here in the background, this is from the comic The Simpsons back in 1998, where up here you'll see Homer Simpson predicting the mass of the Higgs boson back in 1998. So at least some people have understood this for a while. Another thing that Paul Christiano points out is that there's a prediction by Eliezer Yudkowsky back in 2010. Where will we see real AI? That's probably what we would call AGI now. And that's more likely to come from a small group rather than a large industry. That's given as just straightforwardly by Paul Christiano as an example of almost a failed prediction. I don't think I would count this as a failed prediction in the sense that if you mean something like AGI, then the jury is still out. Where will it come from? And the question then is, if it comes out from something like DeepMind or OpenAI, is that like an entire industry that is creating it, or is it like a small group? To some extent, the number of key researchers in DeepMind and OpenAI is not that large. I think if I think you could really argue that if OpenAI or DeepMind were the ones who create AGI for the first time, that would be a small group. I don't think this prediction is horrible, but I do believe that Eliezer Yudkowsky would probably frame this in a different way now than he did 12 years ago. Disagreement 13 is about interpretability, where Eliezer Yudkowsky in his list of lethalities have some central difficulties of sufficiently good and useful interpretability. And this point in particular is one that Paul Christiano is not super happy about. And that is because if you find a number of problems, then the future researchers they can just choose among the different projects that they have in front of them, the ones that don't suffer from this problem. And that's an important thing. Like, just because you can rule out 99% of the solutions doesn't mean that it's doomed at all, because the researchers can just choose among the 1% that don't suffer from the problem. Having said that, what little interpretability research I've seen seems strongly like it does not, in fact, consider the lethalities that Eliezer Yudkowsky is pointing out. Most of it seems like it's only trying to get to sufficiently good and useful interpretability, and that seems to be really hard. But on the other hand, like, you have to solve interpretability to the point where you can say something like, is this AI trying to deceive us, before you can try to figure out what you want to do with that. So to some extent, I think it's fair enough to have that as a prerequisite. Eliezer Yudkowsky is not really, according to Paul Christiano, engaging with the best version of interpretability, the best strategies based on interpretability. And I think it's quite obvious that the strategy that Paul Christiano is thinking about is his own eliciting latent knowledge strategy. And I think Eliezer Yudkowsky, what little I've seen him engage with that, has mostly been very derisively. So I think definitely he should engage much more with that. Paul Christiano gives an example of 5 things from the eliciting latent knowledge report that overlaps with this list of difficulties. I think it's good that there is some overlap, but I think in fact that 5 points is not that much. And I think that this list is in fact something that I think it's more like that the eliciting latent knowledge should engage with the list of difficulties that Eliezer Yudkowsky is pointing out. An issue with trying to predict the future of interpretability research is that you're going to learn a lot more details in the future. And does this overcome the objections? Paul Christiano is framing that as a rhetorical question, and I think, in fact, when I read this, the section B3 with these central difficulties seem like the kind of things where learning details will not fix them. Of course, it's possible we will learn things like that, like there is a simple canonical human understandable version of all concepts, and that would be huge for interpretability research, but that's not really what you would call a detail. I think the objections will not be solved by mere details. That's also probably what Eliezer Yudkowsky, that's why he calls them central difficulties. But Paul Christiano is not really concrete enough that I can say this for certain. Future AI systems. Eliezer considers like the existential qualifiers that if there exists one AI systems in the world which has one way of taking over the world, then that's very bad. So that's a very broad classification, because there are many ways of taking over the world. There are many AI systems potentially in the future, but humans are also manifold, and the existential qualifiers there, that if there exists one human who has this good idea, or one research project that ends up with getting a good grip and a solution to the alignment problem, that's something that gives Paul Christiano optimism that there are this number of research directions, and Eliezer Yudkowsky is, according to him, not taking that into account. I think the way I would state this using quantifiers is the for all quantifier, saying that if Eliezer Yudkowsky have a list of 43 lethalities, then any project need to like pass all these bars. Of course, it's not literally 43 bars, whereas an AI only needs to find a single way to take over the world. That's one way to look at it, like that it's actually not an existential qualifier for the alignment proposals to pass, but it has to pass through all the lethalities. Point 14, how much does Eliezer Yudkowsky know about the state of the art of interpretability? And Paul Christiano's point is he doesn't know very much, so obviously he can't really be that confident in his prediction that interpretability is not going to be successful. I would reserve judgment on this case. I don't know enough about the state of the art of modern interpretability, so I can't really tell that. One thing I will say, however, is that it's not a priori impossible to have a strong opinion about the feasibility of a research field, even if you don't know almost all the details. An example would be astrology, where I have no clue about what astrologers do in practice, but I'm quite certain that it's all bunk. That's of course not to say that interpretability is the same thing. It's obviously not, but it's. I think it's possible to have strong criticism of a field even if you're totally ignorant of the state of the art. Eliezer Yudkowsky has this quote: "There's no known case where you can entrain a safe level of ability on a safe environment where you can cheaply do millions of runs and deploy that capability to save the world." So 3 requirements from Eliezer Yudkowsky: a safe level of ability, a safe environment, and it must be cheap in order to get something that's capable of doing a pivotal act. According to Paul Christiano, this is not engaging with the kind of system that is likely to be built. I have an answer to this that is kind of snarky and maybe not really in good faith, and the reason for this is that in fact the systems that are likely to be built are going to be systems that, like, I don't know, try to cure cancer, or they try to make a Hollywood video or something like that from a transformer or something like that, and the things they will not be doing will be to try to do a pivotal act, and they will not be designed for safety. So in that obvious sense, Paul Christiano is right. He's not engaging with the kind of systems that are likely to be built because they're going to optimize for the number of views on YouTube videos or something like that. Paul Christiano talks about early transformative AI systems doing impressive projects, and has some thought about whether that is possible with like smaller, more myopic AIs that are composed. I think the framing of transformative AI and impressive technological projects is suspect, in the sense that, sure, if you have build something that can cure cancer, that's a transformative thing to do, and it's a very impressive technological project to come up to have an AI that comes up with a cure for cancer, but it's not a pivotal act. And in that sense, it is probably irrelevant, because if you do these beautiful technological things, but you don't flip the game board, then the next AI system that comes along will then be the one to destroy the world. So in that way, for that reason, impressive things are quite irrelevant. The things that are truly transformative in the more pivotal sense is doing things like alignment research. So can you in fact do alignment research by being trained on smaller tasks with short feedback loops and then composing that? That's a good question. My intuition would be that is not something you can get without having a very general AI that is capable of generalizing very far. But it is an open question whether alignment can be thus decomposed. I don't think it's obvious from Eliezer Yudkowsky's point here that it cannot be done, but I do think that if I have to give my probabilities, it seems really hard to have very, very narrow and limited and myopic AI solve the alignment problem. Disagreement 16 is about when problems appear. Eliezer Yudkowsky makes the statement that many alignment problems will not naturally appear at the early passively safe levels of capability. Paul Christiano's answer to this is that we can study the deceptive alignment and these kind of problems before superintelligence, and that is true, but it's also not really answering Eliezer Yudkowsky's point, which is when do these things naturally occur, and not whether it's possible to study them before superintelligence. Eliezer Yudkowsky is claiming that there might indeed be a lot of such problems like inner alignment and what have you, and all of them need to be theorized, recreated, and mitigated in advance. Paul Christiano's answer probably to this is that if we fail to solve the problem of deceptive alignment, then we won't notice other problems such as inner alignment. But that doesn't really affect the probability of solving the problem because we have to solve them sequentially. And I think Paul Christiano and Eliezer Yudkowsky are talking past each other in the sense that Paul Christiano is talking about first we solve this problem and then we solve this problem and then we can see this problem after we have an AI that's strong enough to do deception, whereas Eliezer Yudkowsky is thinking about doing this in advance before we get to unsafe levels of capability. Disagreement 17 is more about engaging with alignment work, even though we did have that in, I believe, disagreement 13. And the statement here again is that Eliezer is not really engaging with the most serious alignment work, and most serious is of course a difficult term. Is there in fact any alignment work that explicitly considers all 43 lethalities? As far as I can see, there is not. Every single alignment problem solution to the alignment problem that I've seen seems to disregard some of these lethalities. So in fact there is a meaningful engagement that is very possible between the list of lethalities and just about every single proposal. And also I must say that I dislike the way Paul Christiano is talking about the most serious alignment work when Eliezer Yudkowsky in his rants starts with saying that everybody in alignment have their own thing that they consider like the key thing and the most serious thing, and nobody agrees what this is, and it's impossible for Eliezer Yudkowsky to like answer all of them. And in this case, when Paul is just saying we should talk about the most serious things, but not really cashing that out to like a concrete statement, like saying something like he's not engaging meaningfully with eliciting latent knowledge. That it's just to some extent answering like Eliezer Yudkowsky has already in his post said why you need to cash this out and say explicitly this is the problem. You can't just assume that everybody knows what is the most serious alignment work, because there is in fact a lot of uncertainty about this. So why do we want to engage? It's important to engage with the best work if you want to, one, assess the probability of doom. Do you actually need that? I think in order to assess the probability of doom, it requires a lot of data and it requires a lot of input, and it requires to some extent both some a clear understanding of the problem and why it's lethal, and an understanding of the alignment work. So I don't think you can assess the probability of doom without both of these things. The second thing is that it's important to engage meaningfully with this most serious alignment work if you want to contribute meaningfully to solving the problem. I think that, in fact, a list of lethalities is a very substantial contribution, in the sense that there is a number of gates you need to pass in order to have some alignment work that doesn't fail for like reason number 27 or something like that. There's a number of people in the comments to the post that disagrees with this. One way I guess you could think about this is consider the classic problem of whether P equals NP. One of the reasons why we strongly believe that P does not equal NP is that we have managed to come up with a real good list of lethalities for any algorithm that purports to have P equals NP. Like there are a lot of gates such an algorithm would need to jump through, and these gates look really, really difficult. And for that reason, we are pretty convinced that P does in fact not equal NP. I don't know if that analogy made sense. And finally, you have to engage meaningfully with the most serious alignment work if you want to be able to complain about other people not making a similar list of lethalities. I think that's just plainly a non sequitur, as far as I can see. That doesn't make sense at all. You can totally complain about other people not producing similar lists without engaging meaningfully with the most serious alignment work. Disagreement number 18 is about evolution and human evolution, and whether natural selection is a good analogy for training machine learning models. Paul Cruciano says it's a weak analogy, and in order to go into details here, it would be really nice to have some kind of pointer to which way, like Eliezer uses this analogy in a number of places, and which of those are Paul Cruciano referring to. So I looked through. There were like three main places where Eliezer uses human evolution as an analogy for something like ML training. The one that is most central, as far as I can see, is lethality number 15, which is that the history of humans was one where we had a relatively stable level of capability, and then a sudden sprint of burst of capability growth, and three things happened at roughly the same time. We got self-reflection, we got contraception, and we started being primarily programmed by cultural rather than genetic factors. And all these three things, to some extent, broke the inner alignment that we previously had with evolution, where we were just trying to spread our genes as most and get as many ancestors as possible, descendants. And the reason Paul Cruciano says that this analogy does not hold is because we can deliberately shape ML training. And he uses the example of animal breeding as a better analogy. It seems to me that Paul Cruciano is really not answering Eliezer here. Animal breeding seems like a bad example in the sense that the animals, like if you have something like the evolution of dogs or something like that, dogs are not getting a sprint of capability growth, and dogs don't have self-reflection, they don't have contraception, they don't have any particular noteworthy culture. So there is no break with inner alignment, no inner misalignment happening in animal breathing as all, as far as I can tell. In this lethality number 15, Eliezer has this particular quote that I'm going to read in full. My model of this variety of reader has an inside view which they will label an outside view that assigns great relevance to some other data points that are not observed cases of an outer optimization loop producing an inner general intelligence. So when I read this seemed really prescient in the sense that this is basically Eliezer Yudkowsky answering Paul Christiano's objection in advance. Like this is not answering afterwards. It is a text that Paul Christiano had access to when he gave the example of animal breeding. And I think, in fact, Paul Christiano probably has an inside view, and he's certainly labeling this as an outside view analogy with animal breeding, and it is not an observed case of an outer optimization loop producing an inner general intelligence. So in that case, in this sense, it seems like Eliezer Yudkowsky answered Paul Christiano's objection in advance. So that was my first thought. My second thought was actually, I've previously complained that a lot of the theoretical foundation on inner alignment rests on like a single example from human evolution, and we don't really have other examples. So in this case, like if we don't have more than one observed example of inner misalignment, then it's a simple, easy prediction for Eliezer Yudkowsky to make that people who will object to this with analogies will have poor analogies, like if there are no other analogies. When I look back on this, I am somewhat in doubt because there are a number of other places where Eliezer Yudkowsky makes reference to human evolution in other lithologies. And it could be that when Paul Christiano is saying that human evolution is a bad analogy, he could be referring to those. I'll briefly go through them. One of them is about whether capabilities generalize and how much they generalize. And it's possible that we can shape ML training to some extent, so alignment generalizes more than capabilities. I think Paul Christiano, the example he gives is to consider breeding animals for friendliness and corrigibility, to what extent that will work. I think just breeding them for friendliness and not also for capabilities. That's a strange example to pull out here, because obviously if Paul Christiano here is referring to this statement by Eliezer Yudkowsky, then here just breeding them for one thing obviously is not very relevant to here, where we are talking about both getting more capabilities and getting more alignments, getting better alignment, better corrigibility. So I was thinking whether it would be possible to change Paul Christiano's example here to not just breed for friendliness but also for intelligence, whether you could do both of that. Could you, for instance, if you got something that was as smart as a human, could you get something that was that strongly identified with like an outer optimization, really cared more about this fitness? I am most confused about whether this is possible. It seems to me that the genes that make up humans basically seem to be selected 100% for fitness and 0% for other things like corrigibility, and but I'm fundamentally unsure about what this line of argument refers to, and for that reason I don't think this is the thing that Paul Christiano is referring to. There's also a third place where Eliezer Yudkowsky talks about ML training as an analogy for human evolution, or human evolution as an analogy for ML training. I don't think that makes that third place makes a lot of sense. Paul Christiano has an interesting analogy about breeding humans for corrigibility. If humans were bred for corrigibility actively, quite likely he expects we would be corrigible up through the current distribution of human behavior. That's an interesting case. One of the things I was in doubt about this is he explicitly writes the current distribution of human behavior. As some people may notice, human behavior is not very corrigible, not very friendly. In fact, humans go to war with each other, and there are many reasons why the human distribution does not reflect the way we behave does not reflect perfect friendliness. So instead, the way I mostly read this is that instead of the human behavior, then I was thinking about like the human level of corrigibility. Could you make us corrigible even while making our intelligence as large as it is now? So if with that breeding process continuously was run by the smartest of the current friendly humans, that seems like it would not break down at the current level of capability, and perhaps even much further than that. So the way I imagine corrigibility is that you are deferring to someone more stupid who doesn't really share your values, and that's the way corrigibility for an AI that is super intelligent would probably look. So can humans in fact be bred for something like that? One example I could come up with was like slavery has been a big thing in the past, where people who were slaves and revolted against their masters generally did not reproduce. So there have been some negative selection. Did that work? My gut is not really, but I don't really strongly know. Mostly I'm confused about this analogy. The overall question, like our values, like how friendly we are, how corrigible are we, is that something we get mostly from our genes, like something that a breeding program could influence, or is it something that we get mostly from culture? My guess is that it's mostly for culture. And the way I would explain this is by changing this analogy here, so it's not actually the smartest of the current friendly humans that are in charge of this breeding program, but aliens. And so the corrigibility is not towards other humans, but towards aliens. So if somehow human reproduction was interfered by aliens, and selecting for corrigibility to the aliens, and the culture, that's the different thing. That is something that is only left to the humans. This seems more like more relevant to having an AI that is a number of perhaps a number of agents or a single agent, and there's a level on top that we're trying to get inner alignment and corrigibility from the agents towards the masters to some extent. Would humans be able to break free of the tyranny of corrigible genes? I believe we would have done that right now, but I am mostly really confused about this analogy. The final disagreement. Sure. Paul Cristiano is using the two words corrigibility and friendliness in the same sense. So corrigibility in this case would be that the AI is seeing itself on the inside in the way that the humans see it on the outside. Something like when we see the AI outside, we know that the AI is not it doesn't understand our true values. It needs to be uncertain about what we truly want. It needs to defer to us, even if it is really sure that we want to be turned into paper clips. And that's the kind of corrigibility that the AI needs to internalize. Yeah. So So yeah. Yeah. Like it's to me part of the reason why I like the analogy better when it's like aliens doing this is to split out the two parts, whether it's like the cultural thing and the genetic thing, where I feel the genetic thing doesn't really have a very strong influence on our value, whereas culture has a huge influence on our values. Okay, the final disagreement is on whether it is possible to verify pivotal acts. Paul Cristiano makes the statement that that is indeed something that is probably possible. And part of the argument he uses for this is that in almost any research and domain, research and development domain, we see that verification is much easier than generation. The much is emphasized by Paul Cristiano. And I think that is strongly wrong, in the sense that verification of something that is like you can build a car and see whether it can drive, but that's very different from trying to detect something that has been built by an adversary, an unaligned AI, trying to figure out whether that contains an error or deliberate sabotage somewhere inside. Adversaries make this a lot more difficult. In software would be an example where it's really hard to see whether someone has deliberately put in some kind of obfuscated bug somewhere. My favorite example of this would be the underhanded C contest, which is an example of people trying to write code that looks really innocent and has some really scary and exploitable bugs in them. And that seems much harder to prove the absence of this kind of attack. I think, in fact, very often in almost all domains, if you have an attacker in something like lockpicking or what have you, then figuring out whether it is impossible to pick a lock is really difficult. And I'm surprised how this point, I think there must be some kind of miscommunication, because this seems like a really basic point. So the example that Paul Cristiano is thinking about here is contributions to alignment research. So to what extent can we prove the absence or convince ourselves of the absence of adversarial inserted problems in alignment research? Can we truly verify alignment research? If it's something that's generated by someone who is stronger, substantially more cognitively powerful than us, then my strong expectation would be no, it is not possible. If we have an unaligned superintelligence and we ask that for a solution to the alignment problem, that's going to end really poorly. Okay, but Paul Cristiano's suggestion is mostly that we are getting this before we have a full superintelligence. How about if it's something at the level of a human? Can that insert errors? I think my expectation would be that it is in fact possible. It's really hard to evaluate whether alignment research does in fact solve the problem. I think it's very easy to come up with like explicit problems with research, but if you get some code from the AI and says run this will be an aligned superintelligence, then I would certainly not trust this. When I'm thinking about this kind of thing, I imagine that, like in a red team, I'm trying to do alignment research as a saboteur and trying to insert errors or something like that. And I think that seems quite feasible. I could easily imagine ways to do alignment research that looks benign, but is actually going down a wrong path to some extent. Paul Cristiano has a suggestion for a way around this. This is in the comments, and that is to require the contributions to come with convincing justification. And as this is not being done by a particular powerful AI, the way we're going to do that, the only way that would be feasible would be optimize for convincing justifications. And trying to do that seems to me straightforwardly really, really dangerous. In the comments further, Paul Cristiano is called on this, and he gives an example of how verification is easier than generation, creating machine learning hardware. And I think that's a clearly not an example of where you would have like this kind of adversarial attacks, even though that's totally possible to have. And I think it seems to me, when I read the comments, that Paul Cristiano is somewhat dodging the question of what do you do if it's not just verification for bugs, but verification of things that are adversarially entered. But again, I am unsure. It seems like a basic point, and it's possible, of course, that it is just me who have misunderstood Paul Cristiano at some point. That is all for today. Thank you, and see you next week.